Accelerated Algebra 2 Stirrup here. We're going to be working on 5K. So we're now going to start looking at the imaginary and complex numbers. And this is where we can do the square root of negatives because we're not dealing with real numbers. So if I were to look at this first problem, as of right now, you would have known this to be an answer of x equals plus or minus 8. And if you were to do this problem, at this point, right before this lesson, you would have said no real solution. And I would tell you that this does have a solution. This has a solution as part of the complex numbers. Complex numbers encompass something called the imaginary numbers. And this would actually have an answer of x equals plus or minus 8i. I is not a variable. It stands for that you had a negative square root. So let's continue on with this problem. All right, so the first thing we have here, it says we have a property. If r is a real positive integer, then the square root of negative r is I root r. Okay, so this is where we start dealing with the imaginary number. So example, this would be an answer of I root 5. This one would be the answer of 2i, because I know the square root of 4 is 2. The I takes place because we had the negative under the radical sign. And then there's the power property. So this is going to come here and here. So I'm going to get I squared. And then root 5 times root 5 is 25. So square root of 25 is 5. So I get 5I squared. And we're going to talk about what I squared equals to in a little bit. But right now we're going to leave it as I squared. This next one, this distributes to both. So I'd get 9 because 3 squared is 9. I squared is I squared. And again, we're going to talk about what I squared means in a little bit. So let's solve this first equation. So I'm going to take the square root of both sides. So x equals plus or minus, square root of 81 is 9, but I have to put the I there because I had that negative under the radical. Problem number 2, if I divide both sides by 3 first, I'd get to that, and then take the square root of both sides. This is going to give you an answer, x equals plus or minus I root 7. Notice where the I fits. It fits before the I, or before the radical. Next problem, I'm going to subtract 10 from both sides. Divide both sides by 3. And I'm going to take the square root of both sides. So I get the I in there. So I get I root 12. But on this problem, we can start breaking 12 down, because 12 breaks down to 4 times 3. So square root of 4 is 2. So on this one, I'm going to get plus or minus 2I root 3, because the 12 broke down. Notice where the 2 and the I is in between the 2 and the radical 3. So that kind of takes place. That's the nicer way of writing it. Problem number 4, if I subtract 5n from both sides, I'm going to get 3n squared on the left side. If I subtract 7 from both sides, I'm going to get negative 3. If I divide both sides by by 3, I'm going to get negative 1. If I take the square root of both sides, I'm going to get n equals plus or minus I. Okay? Because the square root of 1 is 1, and that I comes out. I could put 1i. That'd be technically correct, but it looks a little neater when you just have less information there. Okay, so it looks like I have some things to maybe erase. I'll go to the bigger eraser. So complex number a plus bi. A and b are the numbers. I is the imaginary part of the number. The number a is the real part. And the complex number is the bi part. Okay, the standard form of complex number is a plus bi, where a and b are real numbers, and I is the imaginary unit. So these are some examples of what an imaginary or complex number would look like, where if you look at this, this is the real part, and this is the imaginary part, the complex part. Real part, imaginary part. I don't have anything here, so there's a 0 technically there. 0 to be part of the real part. That's your imaginary part, real part, imaginary part. Okay? So they do indeed exist. All right, it's more erasing I get to do. All right, so pure imaginary number. A complex number where a plus bi, where a is equal to 0 and b is not equal to 0. Okay, so that's where that exists. Anything else? So I have 6i is a pure imaginary number, or plus or minus I, where we're missing out on the real part, so that we're not really counting 1 as a real part, or 0 as a real part of the number. When we're adding and subtracting, add the real number parts, and then add the imaginary number parts. Any square roots must be the same roots. To do. Anything else for me to erase? All right, so when we're doing these problems, like we said before, we're going to add the real parts. So the 3 and the 4, that gives me 7, plus 2i plus 6i is 8i. So we're treating the I like a variable, even though it's not. It follows the same rules, though. 2 minus 9 is negative 7. Negative 12i plus 3i is negative 9i. Next one, 4 minus 6 is negative 2. Negative 3 minus minus, so it becomes plus I. So negative 3 plus I is negative 2I. Next problem, 4 and 2 add together gives me 6. So I can't add because I have the root 3, but I'm going to change root 12. Root 12 can become 2 root 3. And the reason it becomes 2 root 3 is that's 4 times 3, so you take the square root of 4. So I'm going to replace this right here with 2I root 3. So then if I add I root 3 and 2I root 3 together, I'm going to wind up with 3I root 3. Same thing when we have some fractions. So I'm going to make this 2 over 8, get a common denominator. So 7 plus 2, I get 9 over 8. Leave it as improper, please. And I also am going to take care of this. I'm going to make this 4 over 8. Have a common denominator. So 4 minus 5 is negative 1. So negative I over 8. We could also clean this up to go 9 minus I all over 8.
Can I use scratch paper too?
Sure.
Awesome.
All right, so problem number 6. Again, we're going to take care of the fraction. So I have 3/4 minus 5/6. So let's get a common denominator. So we're going 9 over 12. Move that up a little bit. At 9 over 12 for that part. This part's going to give me minus 10 over 12. So that's going to give me negative 1/12. That's the real part. Let's take care of the imaginary part. So the common denominator, I'm going to get minus, let's go 3 over 6i. And then that would be minus minus. So that's actually going to become a plus. So I just distributed it over there. That's going to give me 4 over 6. When we add those together, negative 3 plus 4 is 1. So I'm going to get I over 6. I guess you could, technically that's the correct answer. Sometimes they might want it cleaned up a little bit. What do you think I did here? What do you think I did there? Ask me about that in class if you're not quite sure what I did there, okay? So technically this answer would be pretty darn good to leave as an answer. Whoops, I'm getting fancy colors. That would be okay to leave as an answer, but the other one is a little bit nicer cleaned up. So ask me about that if you're not sure what I did. Okay, so let's start working these out. So this is going to give me 6i squared. Okay, again, we're going to talk about I squared means in a little bit. We'll leave it like that. This one will be 49i squared and 12i squared. Actually, let's go ahead and talk about I squared. So the beauty of I is you have I is equal to the square root of negative 1. If I square both sides, I'm going to get I squared. I squared is equal to negative 1, because if I square both sides, I would get same thing. And then I to the third is actually equal to negative I, and I to the fourth is if I square this right here, if I square I squared, I would get negative 1 times negative 1 is 1. And then it repeats. So I to the 5th is the same thing as I to the 6th, I to the 7th, I to the 8th, I to the 9th, 10th, 11th, 12th, so on and so forth. So with that known, we're going to focus on this I squared is negative 1. So that actually changes this to negative 6. This one changes to negative 49. This one changes to negative 12. Notice the imaginary part went away. This is going to give me 25I squared. Okay, so the negative is gone because of that. And then I squared we said is negative 1, so I get negative 25. And this one becomes negative 3 times negative 1, which is just positive 3. And then we get to this one, 2 to the third. So 2 times 2 times 2 is 8. I to the third. What did I say I to the third was equal to? Yeah, not negative I, right? So I'm going to replace this with negative I, so I get negative 8I. Okay? And again, those are a little different than you've probably seen before, so let's talk about those in class, okay, if you want to go over those. So consider the product. So negative 1, or root negative 1, negative I, 1. This is going to give me negative 1, negative root 1, negative 1, negative I, 1. Notice it repeats. Repeats every 4. Okay, that happens on purpose. So we can start figuring out what these values are. I raised to a higher exponent. We can find out actually what it is. It's only going to be 4 different scenarios that could take place with it. Okay, multiplying numbers. So this is just basic algebra 1. And then FOIL this one. So that's going to give me 6x squared plus 15x minus 14x minus 35, which is going to give me 6x squared plus x minus 35. Okay, basic algebra 1, right? So if we did this one, if I distribute here and here, so I'm going to get 15 plus 10i. If we distribute here, I'm going to get negative 14 plus 9i. If I distribute here and here, I'm going to get 6i plus 10i squared. What did we say I squared is equal to? Right, negative 1. So this is going to turn into 6i minus 10. And the more correct answer would write this is minus 10 plus 6i, because you want the real component first. And that is wanted for sure. Okay, these are all foiling problems. So let's FOIL it. So I'm going to get 10 plus 6i plus 30i plus 18i squared. I squared is negative 1. So I'm going to go 10 minus 18, that's negative 8, plus 36i. If I skipped over something you want me to go back over it, I will in class. If I FOIL the next one, I'm going to get 7 minus 2i minus 35i plus 10i squared. What did we say I squared is equal to? Right, negative 1. So that's 7 minus 10. It's negative 3 minus 37i. FOIL this one. That's going to give me 16 minus 12i minus 12i plus 9i squared. I squared is negative 1, so I get 16 minus 9, which is 7 minus 24i. And then this one, you have to realize that when I have something squared, it means I have 2 of them. So if I FOIL that, I'm going to get 4 plus 6i plus 6i plus 9i squared. So that's going to give me 4 minus 9, which is negative 5 plus 12i. And we'll keep going with these. These are conjugates. So the nice thing on conjugates, the inside and outside terms cancel out. So I'm going to get 4 minus 9i squared. I squared is negative 1, so this becomes 4 plus 9, which is 13. Same thing here, 36. Outside, inside cancel out, minus 16i squared. I squared is negative 1, so this becomes 36 plus 16. So that's 52. And same with this one. I'm going to get 36 minus 25i squared. Oops, 25i squared. I squared is negative 1, so I'm going to get 36 plus 25. So that's going to give me 61. Do I notice about the products? Oh, there are real numbers. Kind of cool. All right, some more erasing we have to hit. So again, two complex numbers, a plus bi and a minus bi. They are conjugates. Products are conjugates are real, always a real number. So if you multiply two conjugate complex numbers together, you get a real number. All right, so what happens when we divide? Well, we want to rationalize the denominator. So I'm going to put both things in parentheses, top and bottom, so we don't do anything silly. So I'm going to multiply the top and bottom by the conjugate, because you don't want to have I as a denominator. Okay, so if I FOIL the top out, I'm going to get 4 plus 10i plus 3i plus 6i squared. Now on bottom, I'm going to get 1. Outside and inside cancel out, so 1 minus 4i squared. Wherever I see an I squared, I'm putting a negative 1 in, so that's going to become negative 6, so 5 minus 6 is negative 1 plus 13i. And on bottom, I'm going to put a negative 1 in there, so that becomes 1 plus 4, so that's 5. Again, let's put these in parentheses. Multiply by the conjugate, so that's one sign difference. So if I FOIL the top, I'm going to get 3 minus 3i minus 4i plus 4i squared. On bottom, I'm going to get 1 minus I squared. Wherever I have I squared, I'm plugging negative 1 in. So that's going to be 3 minus 4, which is negative 1, minus 7i. On bottom, I'm going to get 1 minus negative 1, so that becomes 1 minus minus 1, which is 2. And then this one, we only have a conjugate at the bottom to deal with. And we have the radical down there. 7 plus 2i, root 7 plus 2i. So on top, that's going to give me root 7 times root 7 is root 49, so that's 7 plus 2i root 7. On bottom, that's going to give me 49. The outside and inside cancel each other out. Minus 4i squared. Wherever I have an I squared, I'm putting a negative 1 in, which is there. So I'm going to wind up with 7 plus 2i root 7 all over 53. So simplify the denominator if you need to. So that's going to be 3 over negative 1, which comes out to negative 3. I don't want to have an I in the denominator, so I'm going to multiply top and bottom by I and I. So I get 7i on top. I get I to the 4th on bottom. What did I say I to the 4th was? I had this, I had this, I had this, and I had this. So what is the denominator going to equal? And it's going to give me the 1. So that, which would simplify just to that. And then on this one, I'm going to multiply top and bottom by the conjugate, so 2 minus I. So I'm going to distribute here and here. Wherever I have an I squared, I'm putting a negative 1. I get 6 plus 3, 6i plus 3, and I'm going to have to rewrite that. 4 minus minus 1, so 4 minus minus 1, that's 5. And so the only thing I'd want to clean up is I'd want to make it 3 plus 6i over 5. And again, any of these you want me to go over in class, happy to talk you through it, okay? And that's all we have. Have a great day with everybody. Make sure you get the homework done. Take care of one another. Bye.